Hi everyone, and welcome to this set of videos for National 5 Maths. In this set of videos we're going to be looking at simultaneous equations, and we're going to start off by solving simultaneous equations by sketching the graphs. First of all, what actually are simultaneous equations? Well, any pair of equations that share an equal value of y at an equal value of x are known as simultaneous. What this basically means is that the two equations pass through one coordinate, i.e. a point of intersection. So these types of equations can be solved either graphically or algebraically using two different methods, substitution and elimination, and we'll look at these a wee bit further on. Pause the video just now and write this into your notes jotter. Okay, how do we solve the equations graphically? As I said before, this is also known as finding the point of intersection, so just be aware of that. If you see a question that says that, it means you have to use this method. When we do this, we need to sketch the two graphs using our table of values that we should know how to use already. Once we sketch the graphs, we should be able to identify the point in which the two lines cross, and this is our solution to the simultaneous equations. Again, if you can pause the video and write this into your notes jotter. Okay, here's example number 1. So we're looking to solve the system of equations y equals 3x minus 4 and y equals negative 2x plus 1. So, step number 1 is to do our table of values for each of the lines. So remember, a table of values is made up of x on the top and your y value underneath. So we'll start off by working out the y values for 3x minus 4. So we're going to pick some values for x. Let's just go for 0, 1, 2, 3 and 4. To get the corresponding y values, we need to substitute these values into the equation and work out the y value. So if we do 0 into the equation, 3 times 0 take away 4, we're left with negative 4. And 3 times 1 take away 4 gives us negative 1. 3 times 2 take away 4 gives us 2. Then 5, then 8. Now what you should see here is that you've got a recurring pattern of adding 3 each time. For the second equation, again we have x on top, but this time we have y equals to negative 2x plus 1. And again, let's take values of x to be 0, 1, 2, 3 and 4. And if we substitute these into the new equation y equals negative 2x plus 1, we get the values 1, negative 1, negative 3, negative 5 and negative 7. Again, you should see a pattern here. This time, we're actually taking away 2 each time. Again, pause the video for now and copy this step into your jotter. Right, that brings us on to step number 2. We just need to state the coordinates for now. These coordinates come from the table of values that we've just worked out. So we match it up in pairs of x and y. So if we flip that just now, our first coordinate for the line y equals 3x minus 4 comes from these two values. So we get 0, 4. We then have 1, negative 1, and so on. So if we do this for both sets of lines, we get the coordinates 0, negative 4, 1, negative 1, 2, 2, 3, 5, and 4, 8. So those are the points in which y equals 3x minus 4 passes through. We then have the coordinates 0, 1, 1, negative 1, 2, negative 3, 3, negative 5, and 4, negative 7. Those are the points in which y equals negative 2x plus 1 passes through. Again, pause the video just now and copy this into your jotter. Right, now we're on to step number 3. Step 3 is for us to actually plot these coordinates and sketch the graph. So here we have our x and y axes. We're going to use intervals of 1. So if we plot these points, we'll do y equals 3x minus 4 first. So 0, negative 4 gives us this point. 1, negative 1. 2, 2. 3, 5. And 4, 8. you see that we've got 5 points there that lie in a straight line. So if we join these up using a nice straight line, there we have the sketch of y equals 3x minus 4. So we'll label that correctly. Now, if we do the exact same for the second line, y equals negative 2x plus 1. So the coordinates this time are 0, 1, 1, negative 1, 2, negative 3, 3, negative 5, and 4, negative 7. Again, you'll see that these lie in a nice straight line. So again, if we insert a straight line going through these, and label it correctly, y equals negative 2x plus 1. We've now sketched the two lines one on top of the other. Now from this we should be able to identify their point of intersection, which you can clearly see is this point here. That becomes the solution to our simultaneous equations, which takes us on to step number 4. Before we do that, take some time just now to copy this sketch into your jotter, making sure that everything is labelled correctly. Okay, step number 4 is just to finally state our solution. So the solution to this is our point of intersection. So we need to write here the point of intersection is, we'll now look to the diagram. So we see we come along by 1 and down by 1. So we have the coordinate 1, negative 1. That gives us a solution to the simultaneous equations x equals 1 and y equals negative 1. So both of these equations have the same value of x when they have the same value of y. Right, here's example number 2. So we need to solve the equations 3x plus y minus 3 equals 0 and x plus 2y plus 9 equals 0 graphically. So we're going to do the same thing again. Table of values, state the coordinates, sketch the graphs, and identify the solution. Now, before we can do this one, you should notice that the two equations we have are not quite in the right form. So we need to start off by rearranging these. What we want them to say is y equals. So for the first one, we've got 3x plus y minus 3 equals 0. So let's bring the 3x and the negative 3 over to the right hand side. So that gives us the equation y equals to negative 3x plus 3. And for the second one, x plus 2y plus 9 over 2. We need to bring the x over and then divide by 3. So that gives us y equals negative a half of x minus 9 halves. So we've got some tricky fractions to deal with this time. So insert table of values, you want x and y for both. So starting off with y equals to negative 3x plus 1. Again, we can choose some values of x. Let's go for 0, 1, 2, 3, and 4 again. And we substitute these values into the equation. When we do this, we get 3, 0, negative 3, negative 6, and negative 9. Those then become our coordinates. So our coordinates are 0, 3, 1, 0, 2, negative 3, 3, negative 6, and 4, negative 9. Now we're going to do exactly the same for the second equation. So let's take the values 0, 2, 4, 6, and 8 this time. Chosen these values because we're going to be dividing them by 2 in the equation. We want to find a half of that, so it's best to pick even numbers. So putting these values in, we're going to get negative 9 over 2 for the first one, negative 11 over 2 for the second one, then negative 13 over 2, negative 15 over 2, and finally negative 17 over 2. And again, we can state the coordinates of this. So we have 0, negative 9 over 2, 2, negative 11 over 2, 4, negative 13 over 2, and 6, negative 15 over 2, and finally 8, negative 17 over 2. So these are the set of coordinates that we want to plot on our diagram now. So we'll start off with y equals negative 3x plus 3. So we have 0, 3 first of all. We then have 1, 0. We then have 2, negative 3. 3, negative 6. And 4, negative 9. So 4 dots that lie in a perfectly straight line. So if we insert a line again. Okay, so that is our y equals negative 3x plus 3. And if we do the exact same for the second equation, so we've got 0, negative 9 over 2, so that's 0, negative 4 and a half. So that takes us to here. Then 2, negative 11 and a half. So that's negative 7, so negative 5.5, which is this one. Then 4, negative 13 and a half. So that will take us to here. And then we have 6, negative 15 and a half. And finally 8, negative 17 and a half. Okay, again 4 points that lie in a nice straight line. So if we insert our line again, we should now be able to identify the point of intersection. Now you can clearly see that these two lines cross at this point here. So that becomes our solution. So identify the coordinates of that. We can say the point of intersection is 3, negative 6. That tells us our solution is x equals 3, y equals negative 6. And we've solved the simultaneous equations. Again, take some time to copy this into your jotter so that you have another full example. Okay, here are some questions that you should try. So pause the video just now and try these for yourselves. We'll reveal the answers in a few seconds. Okay, hopefully you've managed to work out the solution to both of these equations. So for the first pair, we should have a solution of 2 and 4, so x equals 2 and y equals 4. And for the second pair, we should have 2, negative 2, x equals 2, and y equals to negative 2. Okay, thanks for listening to this video. On the next video, we'll be looking at one of the algebraic methods for solving these.